Good morning. Sorry I am not there, quote, in person today for you, but a couple of you had asked about these problems last night, so I thought I would just make a video. Feel free to fast forward so you can see if you got them right, or if you already checked your answers, you can fast forward just to the ones that you got wrong. Okay, so it's really important. If you got it wrong, make sure that you find your mistake. Okay? All right. I can't remember which ones I did, so I'm just going to start at the beginning. So we'll start with the first one. So remember, as far as algebraically goes, we've got two ways that you guys can solve systems. So far we've got the equal values method and we've got substitution. Equal values method is when both equations are equal to the same values. Like in number one, they're both equal to y. So I'm going to use equal values method for number one. And what I am going to do there is whatever y is equal to in both of those equations, I'm going to set equal to itself. So then I'm going to have 9x plus 10 must be equal to 7x minus 20. It doesn't matter which side either of those are on because it's equal. All right. Solving this, I'm going to subtract 7x from both sides. Cancels out the x's on the right. And that leaves me with 2x plus 10 is equal to negative 20. Careful there. Then I'm going to subtract 10 from both sides to get rid of my constants on the left. And notice now we've got a negative 20 and a negative 10. Or it's like negative 20 minus 10, but think of it like this. They're both negative, so I'm going to add them and keep it negative. So that would be negative 30. Divide both sides by 2. And that leaves me with x is equal to negative 15. Okay, don't forget that negative sign as well. So I've got two equations, two variables. So far I have one answer. I've got the x. And so I've got two options here. I can either plug in a negative 15, whoa, that's really big, a negative 15 for the first equation, or I can plug in a negative 15 for x in the second equation. It doesn't matter. And in fact, I usually do it in both just to double check that I'm right. So I've got my handy calculator with me right now. I'm going to do 9 times negative 15, add 10, and up here I get negative 125 for y. And then in the second equation, I'm going to do 7 times negative 15, subtract 20, and guess what? I also get negative 125. So I'm pretty confident that is my right answer for y. So x is negative 15, and y is negative 125. As an ordered pair, the answer would be negative 15, the x first, and then negative 125. That would be my final answer. All right. I knew that was going to happen. That's okay. All right, so again, one of the things I love about Notability is I can just write big because I am not good at writing small, and then just shrink it when I am done. So there is the first answer, and then work for it. Okay, in number 2, this is not an equal values method because the first equation does not have one of the variables by itself. The second equation does, and so I'm going to use the substitution method. And so since all of this stuff is equal to y, in the other equation, wherever the y is, I'm going to replace it or substitute it with all of that stuff. So I'm going to rewrite that first equation, and that's 3x plus 5, and then instead of y, I'm going to replace y with x plus 3, and then that equals 23. So all I did was rewrote this equation, except instead of the y, I replaced it with all that stuff, okay? So up here, it's 5 times y, so now it's 5 times all that stuff. So these kind substitution, a lot of times we're going to have to do some simplifying first. And so in this case, I do have to distribute here. So the 3x stays where it's at. 5 times x is just 5x, and 5 times 3 is 15. All that equals 23. I've got like terms here. So I'm going to add them together. That leaves me with 8x plus 15 is equal to 23. And now I'm going to start solving. So I'm going to subtract 15 because there's no x's on the other side. So I don't have to worry about my x's right now. And that leaves me with 8x equals 8. So you probably don't have to put this in your calculator, but dividing both sides by 8 leaves me with an answer of x equals 1. Again, I've got 2 equations, 2 variables. So far I have 1 answer, so I'm going to go up here and plug in 1 for x, and so then y is going to equal to 1 plus 3, so y equals 4. Now, some of you were asking, okay, well, what about the other one? Because you always say to plug it in both. You can totally do that. So if x is 1, so check out what I'm going to do. I'm just going to recopy this other equation. So 3 times 1 plus 5y equals 23. It's a little bit more work because it doesn't say y equals. I'm going to have to solve it. So I have 3 equals 5y, 3 plus 5y equals 23. Subtract 3 from both sides, and I've got 5y equals 20, divide by 5, and I've got y equals 4. So either way, the second equation is definitely a lot easier because all I'm doing is plugging in a 1 and doing this math, boom, and that equals y. The first equation, if I plugged it in for x, I'm going to have to undo it and solve it, but look, I really do get the same answer both ways. So it doesn't matter. If it doesn't matter, choose the most efficient way. So this answer is 1, 4. That would be my final answer. Again, you guys can pause me. You can rewind anything that I did here. Go listen to it again. Make sure you find your mistakes, please. That's really important thing here. Cool. All right, number 3. I am going to use the equal values method again for number 3 because they both are equal to the same values. And so I'm going to set 5x minus 4 equal to 4x plus 6 because they both equal y, so they must both equal each other. So 5x plus 4 equals 4x plus 6. I'm going to subtract 4x from both sides, cancels them out, and I get 1x plus 4 equals 6. Subtracting 6 from both sides. My color coding just got messed up, but that's okay. So subtracting 6 from both sides leaves me with 1x equals 2. I don't need to divide by 1 because it's still x. All right, so if I know x equals 2, I'm going to go back up here. And I can plug a 2 in where there's an x. So 5 times 2, this is where I'm at here. 5 times 2 is 10. 10 plus 4 is 14. Let's check the other one out. 4 times 2 is 8, and 8 plus 6 is 14. So that tells me y must be 14. So my answer as an ordered pair, the x value is 2, the y value is 14. Boom, done. Let's see here. Oh, dang. Oops. Okay. Number 4. This one is not equal values because they're not both equal to the same values. But all this stuff equals y. So I am going to replace y in the other equation with all of this stuff. Now notice the y, it's just one y up there. And so it's going to be a lot easier. I don't have to distribute. So it's going to be 2x plus 7x minus 5 equals 13. Again, there's not a coefficient with y, so it's just that stuff by itself. and I'm good. I still, though, I'm going to have like terms. So I'm going to add 2x's plus 7x's together. That gives me 9x minus 5 equals 13. I'm going to add 5 to both sides. Cancels that out. Forget what color I used. And so 9x equals 18. Divide by 9, and x equals 2. And so if I know what x is, now I'm going to go back up here. I'm going to replace x with 2. 7 times 2 is 14, and 14 minus 5 equals 9. So then y must equal 9. Again, I can go up top here and plug in an x here for 2. 2 times 2 is 4, so I've got 4 plus y equals 13. Subtract 4, and y equals 9. So just to prove to you, you can still use it in both equations. It's just that this one is much more efficient. All right, I'm writing my answer as an ordered pair. The x value is 2, the y value is 9. Boom. Let's make this one a little bit smaller. Okay. All right, number 5. 5 is not an equal values either. I've got x equal to 5 minus y, so I'm going to replace the x in the first equation with my 5 minus y. So that leaves me with 4 times 5 minus y, and then plus y equals 8. I have to distribute. 4 times 5 is 20. 4 times a minus y would be a minus 4y. And then I have a plus y equals 8. These guys are like terms. Remember, it's a negative 4y. So if you got this one wrong, that is most likely the reason. So now I've got 20 minus 3y equals 8. And so the variable term and the constant term are in different spots this time. And so it's the 20 that I need to subtract from both sides. It's a positive 20, right? It's a positive 20, so I'm subtracting 20 from both sides. That leaves me with negative 3y equals negative 12, dividing both sides by negative 3. Oops. And then y is a positive 4. Again, please be careful with your negative signs. So this time I got the y value first, right? And so I got the y value first, so I'm going to go up here and plug that number there. Y is 4, so check it out. 5 minus 4 is just 1. So that means x should equal 1. If I wanted to put it here and I put a 4 up there, that would leave me with 4x plus 4 equals 8. Subtract 4, 4x equals 4, and guess what? X still equals 1. So remember, I got the y value first when I was solving it, but in my ordered pair, the y value is always second, the x value is always first. So there is my answer. Let's change that. Okay, and you did not have to do 6. And the reason you didn't have to do 6 is because I didn't show you guys how to rearrange equations yet. All right, if you have questions about these and you still don't know what you did wrong, please make sure you ask.